Example 2. Solve the quadratic equation by taking square roots. Now, in the last example, we were trying to isolate the x squared. Well, notice this time you actually have these parentheses and it's x minus 1 squared, but really we're trying to isolate the thing that is being raised to the second power. In example A, that's already been done for us. So, we're going to take the square root. We're going to take the square root. On the left side, the squared cancels the square root, and we're left with x minus 1 equals the square root of 25, which is 5. Now, there's actually another option here, because remember in our previous example when we took the square root of 9, we had a solution of both 3 and negative 3. Well, if we're kind of asking ourselves here, what can we take the square root of, or what can we multiply by itself to get 25, can't we also take negative 5 times negative 5? So you have to have two separate equations, and your other equation is also x minus 1 equals negative 5. Solving both of these, we're going to add 1. Our first solution, x equals 6. If I check that solution, I would substitute back in 6 minus 1 squared. 6 minus 1 is 5, and then 5 to the second power is in fact 25. So that checks out. Second solution, add 1 again, but this time be careful because you're adding it to a negative 5. So x equals negative 4. And then if I check that solution, I would substitute back in negative 4 minus 1 squared. So negative 4 minus 1 is negative 5, and a negative 5 squared would be negative 5 times negative 5, which is in fact 25. So that solution works as well. Letter C, 4 times the quantity x minus 3 squared equals 9. Now, once again, here is my something squared. I need to isolate that before I take any square roots. So in order to get rid of my 4, I'm going to divide by 4. That's going to leave us with the quantity x minus 3 squared equals 9/4, and I'm just going to leave it as a simplified fraction. Now I have my quantity squared, so we can take the square root. Squared is going to cancel a square root. We're going to have x minus 3 equals. Now remember, when you have a square root of 9 over 4, we can also write this as the square root of 9 over the square root of 4. We know the square root of 9 is 3. We know the square root of 4 is 2. So ultimately we have 3/2. But keep in mind that when you take the square root, you're also going to have x minus 3 equals negative 3/2. Two separate equations. On our first one, I'm going to add 3. X equals, in order to add 3/2 and 3, we need to find a common denominator. So I'm going to place this over 2. By doing that, I'm going to multiply this by 2, which is going to give me 6. And then 6, 7, 8, 9, my first solution, 9/2. Second solution, I'm going to add 3 again. X equals, just like before, I'm going to find a common denominator of 2, which is going to change my numerator to a 6. This time I have a negative, so 6, 5, 4, 3/2 is our second solution. Example B, 4x squared minus 13 equals 15. This time I'm trying to isolate my item squared, or my x squared, so I'm going to add 13. 4x squared equals 28. I still need to isolate the x squared before taking any square root, so we need to divide by 4. X squared equals 7. Then we're going to take a square root. X equals the square root of 7. Now, the square root of 7 doesn't really come out pretty, so we're just going to leave it as an exact square root. And I'm going to put plus or minus the square root of 7, and I'm going to call that good. Now, I could have written square root of 7, comma, negative square root of 7, but I would also accept if you just put the plus or minus, which takes into account the positive answer and the negative answer. Letter D, 5x squared minus 2 equals 0. Add 2. 5x squared equals 2. Divide by 5. X squared equals 2/5. Square root x equals plus or minus the square root of 2/5. Now, for our purposes, I am okay if you leave that answer. I'm not going to argue with it. If you put that in your TI Nspire calculator, it's actually going to give you a different answer because it's going to rationalize the denominator. So I think it's going to give you 2 times the square root of 5 over 5. If you're getting that answer, that is also a perfectly acceptable answer. But I never went over how to rationalize the denominator, so for our purposes, I'm going to leave the answer looking like that.